right, well, good evening, everybody. It is an absolute delight to be here with you. As Mary covered a lot of the introductions, you know who I am. I call myself a holistic software architect. That whole title really grew out of the fact that it's really hard to explain what it is that I do for a living. My family doesn't even know what I do for a living. In fact, it wasn't that long ago, in fact, my dad called me today, but it wasn't that long ago, I got a phone call from my dad for my birthday, which was a couple months ago now. And we were having the usual semi-annual catch up. And I hear my stepmother in the background. She's like, "Oh, are you talking to Michael? Don't hang up. I want to say hi." Then she goes into another room of the house to pick up a different extension of the phone. This is kind of where my parents live in terms of technology. They're still deeply wired into everything, and that's still pretty cutting edge for them. She picks up the phone. She starts talking to me. She says, "Well, how are things? How's Kate? How's work? Are you still fixing computers for work?" I wrote a book. I explained this to him, so I'm like, "Yeah, I'm still fixing computers for work." And not only that, so for about the last decade or so, I've been working as an independent hands-on software architect. Now, the weird thing is, for most of that, I'm not doing architecture. People hire me to come in and help them solve their architecture problems. And what do I do for the first 3 or 4 months? Everything that's not architecture. Because in a lot of situations, their problem isn't really architecture. It's architecture adjacent. It's everything around the architecture. So it's like, let's solve those problems first, because I promise you, throwing even more code at the problem isn't going to solve it. So we solve those foundational problems. And actually, in a lot of cases, their architecture's pretty good. I did write a book. I'm not trying to sell you the book because nobody makes any money. Well, very few people. I'm not one of those very few people makes money writing technology books. But there were a lot of really cool ideas that are not in print anywhere else, that are very hard to find. And it's been transformative for me. So I figured that book is kind of the culmination of about 7 years of focused R&D, trying to figure out how to make the way we approach software architecture better. Now, of course, a lot of that comes from my experience. Now, somebody told me one day, and I hadn't really appreciated how fortunate I've been in my career. Most architects will get to work on a couple architectures in their entire career. But being an independent kind of consultant, I come in, I get to see a whole lot of different things. I have long relationships with my clients that I'll come back again and again, sometimes to different divisions, sometimes different systems. And so it kind of gives me a chance to collect a lot of long-term feedback. So not only do I get to work on orders of magnitude more software architecture projects than most architects, but I get to see how things evolve and progress over time. You know, one of the most dangerous things that happens in software architecture is that we tend to work somewhere just long enough to make a bunch of architecturally significant decisions, and then we go get the next gig because it's a title bump and a pay bump, and we're getting bored, so we go to the next one. And what that means is you can go through your entire career as a software architect and never have to live with the consequences of your decisions. And then people like me get pulled in, and I only get to deal with the consequences of other people's decisions. So that's really kind of colored my perspectives a little bit. And that's why I'm kind of talking about microservices, because I know it's not new and exciting, and I have a lot of kind of AI-focused talks, but I don't know about y'all, I'm a little burned out on AI. Like, I think we've reached peak AI. We were just having that conversation. I think we've genuinely reached peak AI, for better or for worse. It's probably going to be for worse, at least for a little while. So I'm going to talk more broadly, because one of the things everybody gets excited about is these models can generate code, which is true. But it's not going to solve the structural problems. It's not going to solve the organizational problems. It's not going to solve very much outside of making you faster at generating certain kind of classes of code. And then you get one standard deviation outside of that happy path, and it slows you down. That was the result of the big landmark study where it's like, yeah, everybody says it speeds them up, but when we actually measured, it slowed them down. One of the things I'm going to be talking about next year is kind of going all the way back to the 1980s with the classic book on manufacturing theory that led to lean software engineering and led to the sort of DevOps movement and things like that. I'm going all the way back to the goal. Because what did we learn in the goal? Yep. And all we're really doing now that we're making one piece faster is we're moving the bottleneck. And everybody's talking about how to generate code faster, but that was why the hypothetical fictional business that was talked about in the book, The Goal, was struggling as they invested in automation in certain places in their kind of assembly line. And so they had certain places where everything was really, 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 really fast. Look how much faster it is. We have robots, we have automation, we have AI, or whatever it was in the 80s. And but it didn't make the company more profitable, didn't make them more productive. It actually made everything worse. So that's one of the things I'm going to be talking about next year. But the other thing is that if, let's say, we continue on this path and AI, especially AI-assisted coding, gets massively better, then one, the bottleneck has moved and we need to figure out how to deal with that or not and struggle and have things actually go worse than before AI. Or we solve that stuff too, but then you are no longer a coder, you're a micro-architect. And that means that if we continue on this path that we're on, and all indications suggest that that's true, that's what we're going to end up doing at some point, then we need to stop thinking like a developer and we need to start thinking like architects. So all of this code that is coming out, how are we putting this together? How are we structuring this to get the desirable capabilities and qualities in the system? Because your AI is not currently capable. The best AI models that we have are not currently capable of operating effectively as architects. That's our human job, to orchestrate and oversee these things and guide them into building everything a certain way to get your architectural abilities characteristics. Now we're going to talk about microservices as one of those patterns because that's kind of become the catch-all. This is the latest and greatest architecture pattern. Now, there's a problem with talking about microservices. In fact, how many people are doing microservices right now? Just by show of hands. 1, 2-ish. Okay. And I guarantee you, your systems, your architectures look radically different. Microservices doesn't really mean anything anymore. There's this concept that Martin Fowler wrote about years and years ago. He called it semantic diffusion. That we invent a word or a term or some kind of label for something in our industry. And it's a good term and it's a good concept. And we've connected those things. But over time, as the term spreads in industry, it gets broader and broader and broader in its definition until it's lost all meaning. Microservice is one of those. We don't really have a good definition. REST is another one. Like everything that you've ever seen in your life that anybody called REST doesn't qualify as REST. And I'm saying that knowing full well that I don't know everything that you all have seen, but I am that confident that you have never, ever in your life seen a true RESTful system, just things that are called REST. And because our definition of REST has devolved so much, basically, if you're using JSON and HTTP, we're going to call it REST. Even if it's RPC, even if you're not using the resource abstraction, even if you're not using Helios, which, anybody ever used Helios? Okay. Hal, probably. What kind of hypermedia did you use for your API? Okay, cool. Okay. That's... although not very relevant for a very long time, REST was coined in 2000, describing the work that Roy Fielding had been doing the previous decade on the web. But, it probably didn't really matter that we were building APIs and trying to call them RESTful and not worrying about Helios. But now it does. It's actually super valuable, super useful. But there's so many different definitions of microservices in the wild. I'm going to speak at a little bit of a higher level. And what I want to do is I want to give you 6 hard-won lessons from many, many client engagements, many, many mega disasters, so that maybe you are forewarned and forearmed so you don't end up in the same situation. So let's start at the beginning. The first secret, the most surprising secret. Nobody actually wants microservices. I've never met anybody who actually wants this. They might think they want this. They might ask for this, but nobody really wants microservices, right? So what do they actually want when they say, oh, yeah, we're hiring an architect, we want to build microservices. We want microservices. No, you don't. Tell me what you really want. What do they really want? Well, they want organizational agility, and they're pretty sure tiny pieces are going to magically make that appear. They want a reasonable release frequency. Again, that's kind of a function of the organizational agility. They want a release confidence. They want room for growth. They want to be able to scale. They don't want to like hit a wall just as everything is going really well. They want enforced modularity. Maybe they want a more efficient use of compute resources. Maybe they just want an architecture that they won't be ashamed of, because we've all been there, or most of us. If you haven't, you will eventually, trust me. I promise you, future you already hates the code and the systems that current you is working on. Like your future you is gonna hate the work you're doing now. That's just how things go. So why does everybody obsess over microservices? Well, my friends Neil Ford and Mark Richards, they actually wrote a book. I've been friends with them for a very long time now, 10 or 15 years, and I've been watching their material around architecture evolve. And one of the things that they created was this. This is their architectural scorecard, where they have different architectural patterns, and then they give them scores, a rating of 1 to 5 stars. And so when you look at this and you see like the humble monolith with all its 1 stars, and you see microservices with all the 5-star capabilities, it's easy to understand why there's such an emphasis of microservices. And in fact, Martin Fowler talking about this. As microservices were starting to become more common, this is about a decade ago, we've seen many projects use this style in the last few years, and the results so far have been positive, so much so that for many of our colleagues, this is becoming the default style for enterprise applications. Sure, because 5 stars, who wouldn't want 5 stars? But what the hell does 5 stars actually mean? Like, what does that really mean? Yeah, we know 1 to 5 stars as a rating system. 1 is bad, 5 is excellent. So one night, I'm on DoorDash because I am lazy and I would rather go broke than cook certain nights. So that's what I do. And as I'm perusing the local options, I find a local fine dining establishment, nothing like the kinds of truly wonderful cuisine you can get here in Chicago, and terrible, but also wonderful. I'm going to see if I can bring a bottle of Jeppson's Malort home with me, and I'll talk about why a little later on. But here we are, Eddie Merlot's prime aged beef and seafood, flown in daily. 4.5 stars. 4.5 stars, that's obviously good. Now, there was right next to this, in the listing of local restaurants that would deliver to my door, thanks to the gig economy and horrifically underpaid people, which I am grateful for, there was another option that was 4.2 stars rating. Now, you would expect 4.5, 4.2. I mean, we're in the rounding errors at this point. So you would expect that 4.2 star option to be comparable, right, with this very high dollar fine dining steakhouse, right? So 4.2 stars is McDonald's. We don't have a standardized scale. You know, my wife has a hobby. And her hobby is every time we go somewhere that is truly magical, that is like out of this world, never forget, lifetime memory, core memory, like fantastic experience. We go somewhere. We went to a restaurant in Italy. It's called Solo per Due. Only for 2 is what that translates to. And it's a restaurant where they do 2 seatings a day, lunch and dinner. And if you book dinner, it's your restaurant for the night. They make the menu for you. They decorate the place for you. 1 table. And it's a truly incredible experience. Also surprisingly inexpensive for what it was. And my wife that night, we actually stayed in the little village where this restaurant's located. There was a little stone cottage in an olive orchard in a tiny village in kind of the countryside in Italy, about an hour or so outside of Rome. Beautiful place. And we're in there and she's on her phone. I'm like, what are you doing? And she says, I'm reading the 1-star reviews for this place. Because no matter how great it is, somebody somewhere is going to find something to kvetch about. And that's just kind of been her hobby ever since, every time we go somewhere. And that's another interesting thing that she discovered, is we went to a place that was really wonderful. And what surprised her was that the very reasons that she loved that place were the exact same reasons people were giving it 1-star reviews. We were staying in a villa in Bali. By the way, I'm embarrassed about this. My wife is smarter than me. I knew that, but I'm still embarrassed at the different ways it shows up. I'm looking out to the east off the coast of Bali, and I see in the distance something. I can't tell if it's clouds or an island, because right on the edge, limit of my visibility. I said, is that clouds or is that another island? She says, it's an island. I said, oh, she said, it's Lombok. I said, oh, Lombok, like Project Lombok. I wonder if they know. And my wife just looks at me. And I said, what? She said, we're on Bali. I said, yeah. I said, and she said, in that direction is Lombok. I said, yeah. She said, what's the island in the other direction? I said, oh, that's Java. Oh. Like I said, she's smarter than me. But our 5-star ratings, our 4-star ratings aren't created equally. Our 1-star ratings aren't created equally. But we kind of treat them all the same, this lowest common denominator. XKCD kind of nailed it with this. 5 means it only has 1 rating. 4.5 means excellent. 4 means okay, and then everything else is garbage. And then we went to Tokyo a couple of years ago, and we found this incredible sushi place. And she was stunned that it had an average rating of 3.1. And then all the really amazing places were like in the low 3s. Like it was super hard to find a 4 or a 5. I finally found out why. Because in Japan, they actually standardize what the star ratings mean. 3 means as expected. 2 means it could have been better. Like this example. Yes, I've definitely noticed they're much more harsh and tend to have a very alien approach to rating things to me. I had a fantastic meal. The price was cheap. I'm happy I found this place. However, there was a plastic bottle rolling on the car park. I wonder if the boss knows. 2 stars. And somebody said, yeah, 3 means as expected. Over here, 5 means as expected. So what is that 1 star telling us? It's not giving us very useful information. So let's break this down. Let's quantify this. So obviously, one of the famous success stories with microservices is Amazon, going all the way back about 25 years when Jeff Bezos issued his infamous platform rent. And he says, we're going to build everything this new way, and you're just going to have to deal with it or you're fired. And nobody understood why. Why are you making a bookstore an extensible, programmable platform? And he's like, it's not your problem. That's my problem. Your problem is to build it. Or not. You can go. And so people started doing that. And Amazon has been very successful. They are very scalable. In fact, if we look at agility and deployability, Amazon's doing 136,000 deployments a day. So that's what 5-star agility means. Like we're hitting the ceiling. What about elasticity and scalability? Well, Amazon is peaking out during Prime Day at over 50 million HTTP requests a second. So let's contrast this with the humble monolith. Somebody in the same domain, in the same kind of area of business, e-commerce. Let's look at Shopify. Shopify famously has a monolith. They have the largest and oldest Rails monolith that is in existence. And they're proud of it. People ask them from time to time, are you going to decompose this into microservices? They say, why? Well, let's look at the same stats, because for agility and deployability, the monolith is only 2 stars. That's got to be bad. But honestly, they're crushing the rest of us. Anybody here doing 1 deployment a day? 1 deployment a week? They're doing 40 a day. They got a bunch of teams working on this monolithic code base, doing 40 deployments a day, confidently. What about scale? Now, obviously, Shopify is not Amazon. They aren't Uncle Jeff's everything store, but they sell a lot of stuff. And not only that, some of the people who sell on Shopify, they have rather substantial followings. Wouldn't that be nice? And they do limited edition merch drops, and that causes huge spikes in traffic. But they handle it just fine. So typically they're looking at about 1.3 million requests a second on that monolith. So they're scaling fine. So 1 star, bad, but this is still larger than anything the most of us are working on at any given time. So maybe we need to look a little more broadly. This is why in my book, I changed, I built quite a bit on top of the work that Mark and Neil did in their books, but I thought it was a little more useful rather having this catch-all of 1 star being the bottom, where it could be like way below the bottom, it could be at that bottom or whatever else. We have a positive and negative set of extremes. And when we talk about 5-star agility, who doesn't want 5-star agility? But when you talk about extremely high or extremely high scalability, that's a different conversation. So it's a useful way of framing it. So this is the way I kind of go into some of this stuff in my book. But because we had been conditioned to think that this architecture is the panacea, it is the golden hammer, we tend to over-deploy it. And we tend to over-deploy it without really understanding the risks and the complexity that we are volunteering for when we adopt an architecture like that. And this is why, not that long after Martin Fowler's original blog post, he followed up with this. As I hear stories about teams using microservice architecture, I've noticed a common pattern. 1, almost all the successful microservices stories have started with a monolith that got too big and was broken up. 2, almost all the cases where I've heard of a system that was built as a microservice system from scratch, it has ended up in serious trouble. This pattern has led many of my colleagues to argue that you shouldn't start a new project with microservices, even if you're sure the application will be big enough to make it worthwhile. So this is 2015, but we were still peak hype cycle of microservices until we got into the trough of disillusionment. And then even Gartner, unironically, embodied the Gartner hype cycle, because Gartner was predicting around this time that by 2017, everything will be microservices. And then in 2017, they said, by the end of 2019, 90% of organizations who try to adopt microservices will fail. They will find the paradigm too disruptive. Now, I can guarantee you, it's not that they didn't know what they were doing. Like, sure, some of them don't. A lot of people don't. But even the people who know what they're doing, with very experienced and sophisticated developers and architects and organizational buy-in and everything else, they're still going to find these failures. So there's more to this. And in fact, a few years ago, I found myself driving across the state of Wyoming for my sins. Wyoming is an odd place if you've never been. I don't recommend it. But I'm on this stretch I'm from there, so I can, talk bad about it. This is like my home state. And I was driving diagonally across the country on this desolate stretch of highway. I'm on this highway hours. I don't see a soul. I don't see another car. I don't see a town. I didn't see any wildlife, just like sagebrush and dirt and highway. Then out of nowhere, I start passing through a town that I didn't expect to see. Wasn't really on my map, on my route. It's like, where did this come from? And as I'm going through this town, something feels off. Something's not quite right. Sort of like if you ever watch a horror movie and you're in the first act of the horror movie where you haven't had your inciting incident yet. And there's just like a vague vibe of something is wrong, but you don't know what yet. You're going to find out. The slasher comes out, or the ghost comes out, or the gypsy curse is dispatched, or whatever else. Just something is wrong about this place. And then it hits me. There's nobody here. It's a modern town. passing a very impressive looking high school, a lot of houses, businesses. Everything is closed down. There is nobody living in this town. It is a ghost town. It was a town that popped up in the 1970s to support a mining operation. The mine closed in the 1980s. They were mining uranium. There was a big boom for a little while during the Cold War and all of that for uranium. And then suddenly, fall of the Soviet Union, 3 Mile Island, Chernobyl, stuff like that. Like we were less excited about uranium and we weren't buying it like crazy fast, and the market dropped and it was no longer economically viable to mine uranium. So the mine shut, everybody left. It was a ghost town. But as I'm driving through this ghost town, I see a sign of life. I see this little business right here, Monk King Bird Pottery, in what appears to at one point to have been like a mechanic shop with gas pumps, but the gas pumps are gone. This is all different. And a guy basically bought this building and a whole bunch of land for like $5,000, and he decided that this is an ideal place for my pottery studio. So I met the man. That's Byron Seeley, aka the Mad Potter. Dude is a drinker, by the way. It was like 10 in the morning. He was slobbering drunk. He had a big red Solo cup in his, and you could just tell looking at him, this is not a sober man. But, and I respect him. He's a very talented man. But he's got a red Solo cup filled to the brim with vodka. The breakfast of champions. And I'm chatting to him. He's showing me around his live-in studio, his retail space. I buy a few pieces. But I can't help but wonder, why here in a ghost town on a highway that nobody drives on? So I asked him, I said, hey, Byron, do you get a lot of business here? And he kind of looked at me and belched, a very flammable belch, and said, what's a lot? I was unprepared for the follow-up question. So I said, I don't know. He says, I don't either. I know what enough is. I get enough. And that just really stuck with me. See, we don't want a lot of this stuff. We want enough of this stuff. Because every time you make these ilities, these architectural characteristics stronger, it comes at a cost. And you're going to pay that cost whether you need extreme scalability or not. You're paying a price for that. Architecture is all about trade-offs. The thing is, these things still matter. But is the microservices architecture the only way to get them? Or can we take a more nuanced approach to deliver enough where we don't lose this room for growth? Now, I'm going to talk about that in a minute, because a lot of people go to microservices because migrating to microservices is perceived as hard. So the first secret, nobody really wants microservices. They want something they believe that microservices will give them. The worst mistakes I've ever made in my career as a software architect is somebody says, okay, we want to do microservices. Like, okay, I'm sure you've thought this through. I'm going to help you out. And then I led them down there, and it was a disaster. The worst thing that's ever happened, we over-engineered the snot out of this architecture. The division was shut down. Everybody lost their job. 35 teams of people. Because we over-engineered to a breaking point. Because we were sure that someday we would want microservices. And we didn't build ourselves a path to get there. We tried to go from like 0 to 100 in a quarter second. And it didn't work. Now, so from that experience, learn from my experience. When somebody say they want microservices, I say, okay, I'm glad you got that off your chest. Now let's talk about what you really need and start going that direction. But the second problem that makes all this difficult is there's no single definition of microservices, right? But we've all worked on things that we would call microservices. So now you've got teams and teams and teams of developers, and you've done your due diligence, and they all have microservices on their resume, but they're all describing a different architecture. And a big problem we have is historically we've had a very flat taxonomy of software architecture. Well, there's the monoliths, and distributed. And we try to fit everything into this narrow system of classification. Now, what happens is we end up with these increasingly overloaded labels. Oh, well, all the monoliths are the same, all the microservices, all the distributed systems are largely the same, because you point to a system and say, that's microservices. Okay, cool, that's microservices. Got it. I'm going to file that away in my brain. Then I go to the next gig, and they say, yeah, we're doing microservices. Oh, that's really different to what we were doing over there, but I guess if that's microservices too, then what do these have in common? Oh, a bunch of tiny pieces. And then we end up defining these architecture patterns by the lowest common denominator, by the topology, which is not super useful. So, and the other problem that's even more dangerous is we associate the capabilities of the architecture with the topology. But that's not necessarily where those architectural capabilities come from. Scalability, elasticity, deployability, testability, agility, etc. All these ilities, all these words that usually end in ility. But we end up focusing on that rather than the actual important details that led to the creation of these patterns in the first place. And in fact, Martin Fowler even says this. Well, there's no precise definition. There's certain comment. He's very vague and hand-wavy about what all this stuff means. But the reality is, breaking an application into hundreds of tiny pieces doesn't magically make all the architectural ilities appear. In the same way, if you have a monolith, that does not presage a big ball of mud. All of these are a product of decisions, architecturally significant decisions. Now, there's no single correct set of decisions, but people like to believe there is. One of the things that makes me depressed about our industry, I was at a conference in Budapest a couple of years ago, and I saw there was a speaker. He was giving a talk, and I think the byline of the talk was the unreasonable efficacy of simplicity. I was like, well, you're talking my language. So I go in there, and I sit down. I got my notebook. I got a seat right in the front, and I'm listening to this guy talk. He's talking about eBay back in the 90s, and Yahoo back in the 90s, and Amazon back in the 90s, and all these were gigantic monoliths. And then he talks about how they outgrew their monoliths and they did all these things. And then he says, nobody ever starts with microservices, but we always end up there. Therefore, follow these commandments in every system you build. And I'm sitting there listening to this, I'm in the largest room at the conference, standing room only. I'm looking around, people are lapping this up. They're like, okay, so always do this, always do that, always do that, always do that. There's no best practices in architecture. There's only trade-offs. And we bypassed all of that, all of the actual critical thinking that we need to be effective as software architects, and boil it down into a set of rules that we blindly follow. And we wonder why we might keep getting better at code, but our software keeps getting worse. Have you noticed that more and more software just sucks? Like major core user journeys through enormous businesses are broken constantly. It's almost every other day that I'm trying to use somebody's crappy web app that bootstraps 8 million lines of code and can't do a basic thing. I can't just click next because something broke somewhere. And I'm in the console debugging their app so I can make my freaking insurance payment this month because their web UI doesn't work because they only tested in Chrome because it's the only browser in the world. And even using a Chromium-based browser is not good enough anymore. It's like we keep getting worse at a lot of this stuff. But that's when I realized that nobody was ever going to buy my book, because I don't tell you what to think. I give you tools that teach you how to think about these problems. And ain't nobody got time for that. The rate of change right now, just tell me what to do. Just tell me what good looks like and I'll do that. But it's not that simple. And so somebody somewhere might struggle with microservices for 4 or 5 years before they finally get it dialed in. And then they write a book. I've cracked the code. Do exactly what I did, and you'll have my success. Except you're in a different business domain, different line of business, different organizational dynamics, different everything. And we want to think that there's a one-size-fits-all answer. But that's the beauty of software, is that we can form it and shape it and adapt it to our needs, rather than trying to be this like Swiss Army knife that can do a lot of things but nothing well. So there's no correct set of decisions. And you either get books that say, oh, this is what we did and it worked for us, so you should do it. Or you get books that say, hey, here's all the different things you have to think about. Here's how to think about them. And that's not a very popular line. It's an easy thing to sell. So, and even then, if you're doing this, even if the architect does their due diligence, they read Sam Newman's book, they read my book, they read Chris Richardson's book, and they're finally wrapping their head around the nuance and complexity and depth of this style of architecture. If you're the architect, you're not the one building it. You got a bunch of teams that are building things. And you can't just expect that they're all going to do the same amount of work that you did. Just read these 2,000 dense pages on architecture, and then you'll be ready. Good luck with that. That's another lesson I learned the hard way. The thing is about patterns. Patterns are supposed to be high bandwidth mechanisms to communicate an idea. But that only works if we have shared definitions that we're applying the labels to. But there's such a variety of things that we're calling microservices that at any meaningful scale, there are no shared definitions of any of these patterns. Some of them are a little easy, but because of that fact, we end up over-focusing on the topology, and we just assume the big ball of mud is the same as all the other monoliths. And that's not true. The big ball of mud, coined by Joe Yoder and Brian Foote. A sprawling duct tape and baling wire spaghetti code jungle. Right? Expedient repair. Information is shared promiscuously. Nearly all the important information becomes global or duplicated. The overall structure of the system may never have been well defined or eroded beyond definition. And like, nobody wants to work on these. We end up doing it for better or for worse, but right? We're kind of clear in this definition from this paper from '97 popularizing this term, the big ball of mud. And when you realize that now some of these are actually structured, we have varying levels of structure in these other monoliths versus no structure. And so we can't define an architecture by the lowest common denominator. Now, to get around definition, Mark Richards was fond of saying a microservice is a single-purpose, independently deployable unit of code that does one thing. Well, this is true, but it can lead us in the wrong direction. Now, we want to do the pattern right, but only if the pattern is right. We want to be cautious of pattern-driven architecture, but that is the state of the art. That's how most of the industry operates today. Pattern-driven architecture. And we wonder why the failure rate of projects is so high. Patterns aren't architecture. Patterns are a side effect of architecture. And so we've been overdue for a more comprehensive architectural model where we're not focusing on the patterns so much. The patterns are just like examples to be learned from, but we want to focus on the decisions, the core architecturally significant decisions, because in every project there exists a set of decisions. Now within that set, there exists a subset that directly impact the architectural abilities and their measure. So when we look at these different patterns, as diverse as they are in terms of topology and implementation and capabilities, each of these is just a result of a handful of architecturally significant decisions. Decisions around granularity, topology, how we define module boundaries, how we define component boundaries, data persistence, isolation of data persistence, constraints around code reuse, whether we're communicating synchronously or asynchronously, or what the rules are around that. So these are all built out of what it turns out we have had for years, and we just haven't taken advantage of it. Essentially, a periodic table of architecture. The atomic primitives that we combine in different ways to get different outcomes. Everything in a modern world is mostly different configurations of the same 108 or so basic elements. I know there's more elements, but some of them don't really exist in any meaningful way. And it's the same in architecture. These decisions show up again and again and again. And these are some of them, they're not all of them. But essentially, each one of these atomic primitives is a constraint. So if you think about the big ball of mud, what defines the big ball of mud? It's a free-for-all. You could do anything you want. There's no rules. Where's your God now? Make everything global. Make everything public. You want a 30,000 line God class? Have 5. It's a free-for-all. And you get a mess. But what happens when you start constraining the degrees of freedom? How we define the module boundaries, how we communicate, our component granularity, all these different things. That was what Shopify did. They said, okay, well, we want these sets of capabilities are enough. So what is the minimum set of architecturally significant decisions that would induce enough of the things that we need? And so they ended up with a monolith that borrows a lot of ideas from microservices without all the complexity. Now, I told you this is something that's been around for a long time. It's not a new idea. I discovered it when I read Roy Fielding's, I mentioned REST earlier, or foreshadowing. Anybody actually read Fielding's paper, Architectural Styles and the Design of Network-Based Architectures? Anybody? Well, if you had, the odds are you've only read chapter 5. Because chapter 5 is where he talks about REST. But that paper wasn't about REST. It was about architectural styles and the design of network-based software architectures. So people go to this as the lowest level, the foundation that all this talk of REST is based on. And then they get angry because he doesn't talk anything about APIs in there. How to design your API or anything else. Because he wasn't talking about APIs. He was talking about architecture. But that was the core of this doctoral dissertation. It is worth a read, by the way. I highly recommend it. It's very accessible as far as doctoral dissertations go. And when I read that the first time, I was trying to understand REST better. So I read all of chapter 5. I didn't understand REST any better than I did before, so I read it again. I still didn't understand it any better. So I read chapter 5 and 6. I read it to the end, starting in chapter 5. I still didn't understand it. And then I was getting angry. And then I read it all the way through, and he didn't talk about APIs anywhere in there, and I was mad about that. And then I read it one more time. And then I understood it. I was like, oh, because he's talking about design by constraint, about constraints being this periodic table of architecturally significant decisions that you put chlorine and sodium together, you get something that is different than sodium and different than chlorine, both of which will harm you or kill you, but together makes your pizza taste better, and it makes my fingers swell, so I can't wear my normal wedding ring. But I'm here for it. I'm in Chicago. Of course, I'm having some Lou Malnati's. So, Fred Brooks was talking about in the 70s. One of the early books on software architecture, Perry and Wolf, talked extensively about constraints. We saw it again in 96. Fielding's paper. There's a great paper, Software Architecture Constraint, Reuse by Composition, really kind of explored these ideas deeper. And then my book and the tailor-made software architecture model. So this isn't new. This is where we got this concept of an architectural style. Now, we tend to think of styles as like broad categories of things. I have a very, elder millennial style. Middle-aged man with a fish shirt, graying hair, blue jeans, right? That's a style. It's a choice. It's not a good one, but it's a choice. But architectural styles in this context actually means something very specific. An architectural style is a very precise definition of a pattern, because it basically, you put this set of constraints together, that's the style that you have. You violate one of those constraints, no longer that style. That's why Roy Fielding spent about a decade after that paper was written arguing with strangers on the internet about how they don't understand REST, and then they would mansplain REST to the guy who invented REST, and then finally he's like, you know what, I'm done. And he just disappeared off the internet. And good for him. I wish I was that smart. I actually asked him to write the foreword for my book. He ignored me. I wasn't surprised. So let's look at this. let's look at these patterns. We look at microservices, right? Like these are the kind of defining constraints that we have. Now, this is not enough to build a system. This is just the foundation that we will extend and adapt to fit what we're building. This is why I call it an abstract style, because just like an abstract class, you don't really want to directly instantiate it, but it's a good template that you can build on top of. So I don't think we should throw away the patterns. I think we should just use them more as templates and be more mindful about the decisions that we make. Another fun fact that falls out of this whole model, if you are doing AI-assisted coding, what's one of the biggest problems that we have? These models go off the rails, do all kinds of crazy things all of a sudden. It's like, hey, where's all my data? Oh, whoops, I did this force migrate reset with your DBOps tool, and yeah, that dropped your entire database. I shouldn't have done that. And then my favorite thing about the AI is either when it does something terrible and I confront it, instead of fixing it, it summarizes my feelings for me. That's helpful. Or it'll just apologize and then do it again. But it turns out that if you are the micro architect and you are orchestrating these models to do AI-assisted coding, but you are in the driver's seat, you are the human in the loop, you are trying to corral these things into a desirable outcome, constraints are super useful. They are things that you can check, that you can programmatically check, that you can validate. These are constraints that you can make your models work within, and generally you get more consistent results on the other side. So even though my book's not really about AI, when you start applying the same ideas to AI-assisted coding, really incredible things start to happen. And so the model is called the tailor-made software architecture model, and it gives us some foundations to avoid looking at things, missing key things. So the third thing I've learned is that the trade-offs are more than we expect, right? Going back to this, I can guarantee you it's not because 90% of organizations that try microservices get the constraints wrong. Remember, we talked about Amazon being very good at microservices. Even they said, yeah, no, not for this. We're going to put it back in a monolith, and everybody was happier, and everything was cheaper and better, and they moved faster and everything else. Now, this is a loaded headline, and I'm not going to get into it. I'm not going to get into any of this story, but the key thing is, despite having a lot of capabilities, they don't always fit. And the other thing that I think we have to be mindful of is that, like, microservices wasn't an idea that was waiting to be discovered. It's not like gravity that one day Sir Isaac is chilling under a tree and an apple falls on his head and he's like, oh, what goes up must come down. That was an idea that was waiting to be discovered. Microservices emerged due to a lot of other things that were happening in the 90s and the early 2000s. Right? We look at this. Nobody just suddenly realized, oh, tiny components. That's a panacea. If I were to go back in time and give a talk at a conference somewhere, go back to like 95, 98 even, and I start talking about my new idea for this, I go Austin Powers, and I'm like, I have this brilliant idea for a new architecture. I'm calling it microservices. And I lay this whole thing out. They wouldn't look at me like I was a visionary. They would look at me like I was crazy. Because what I was describing wasn't new, wasn't radical. It was impossible. We couldn't do that. This pattern only emerged after a number of influences were starting to come into play. Changing cultures, advancements in technology, evolving practices, new organizational theories. These are the X factors that made microservices practical, at least to a limited extent. Well, one of the first ones was the influence of the Agile Manifesto. Now, I realize, like, I'm getting old, and like I've read the Agile Manifesto, and a lot of people haven't. You can read it; it'll take you 5 minutes. Like Fielding's paper, it doesn't tell you what to do. It doesn't give you a blueprint. It's just a set of ideas that these people basically. All right, let's go back to the 90s. My career started I started my career before Agile was a thing. Yeah, we did waterfall, we did all that stuff. But think about it, right? In the late 90s, there were PCs on most desks. And companies were realizing, hey, we need to start moving processes and all of this business functions into the computer. But we didn't have SaaS yet. We didn't have like a long tail of SaaS or, where we're doing everything in like Jira, Workday, and like one other Teams. I don't know, Microsoft Office, right? Office 365, where we're trying to shoehorn everything into those 3 suites. We didn't have a lot of this stuff. So when people needed stuff, they would go to companies like mine back in the day and say, hey, would you build this thing for us? And we'd say, absolutely. It was really fun because we were always building new stuff that didn't exist before. Now we just kind of glue together NPM packages and we call ourselves senior developers, but it doesn't feel the same as it did back in those days because they're like, we were really making stuff, or I don't know, maybe I'm just getting old and nostalgic. But when you were building software like that, people always wanted to know 2 things. How much is it going to cost? And when is it going to be done? And so they want a fixed cost and a fixed schedule. And they want fixed features. So you had to kind of lock the process down because if you weren't careful, we knew the reality of software, the very act of delivering software will change the requirements. We know Schrodinger's spec. You can know what the customer wants or what they need, just not at the same time. And so we would go through great lengths to make sure that we had dotted every I and crossed every T up front before we started building. We present them with this giant document that says, this is what we're going to build, this is when it's going to be done, and this is how much it's going to cost. And we locked it down so hard that when they realized that they were inadequate in what they asked for, they'd say, oh, this isn't quite right. Well, this is what you signed, so that's what you're getting. But we can fill out a change order contract and we can quote you for the change. And they're like, yeah, we'll make it work. And the thing is, this is maybe the most fundamental thing that we need to understand about software. We don't build things. We change them. Software development is just a deeply nested set of change cycles. That's all it is. But we optimized for the building, not the change. But the changing of things is what we do most of the time. So that was what the Agile Manifesto was all about. Realizing the inevitability of change and reprioritize. So we're optimizing for change rather than optimizing for one-off construction. So that had to happen. That led to a lot of this stuff. We had emerging practices. So microservices, depending on... Let's see. So depending on who you ask, microservices largely came from... There we go. Microservices largely came out of ThoughtWorks. ThoughtWorks, around the dot-com bubble boom, if you remember that, the bust, the bubble bursting, which did kind of come with a boom, but not the kind of boom that I'm implying. A lot of the extreme programming practitioners kind of all ended up on the street looking for a job, and ThoughtWorks scooped them all up because they really believed in a lot of the ideas behind the XP people. And so they were doing XP. Test-driven development, constantly. Pairing, constantly. Very, very, like constant interfacing with the customer. Constant demos, continuous integration. Like all of these practices that today we pay lip service because we want to be buzzword compliant. So most organizations, they want to do just enough that they can check the box, says we're agile, because, you know, we have Jira or we're using Safe or whatever. They renamed the ops team to DevOps so we can say we're doing DevOps, even though that's not what DevOps is, but whatever. But the thing is, that was key. And most people who want to do microservices aren't doing the things that started showing up. They don't pay attention to domain-driven design. Like we knew, it doesn't matter how you design your architecture, you're going to ship the org chart. Like We knew that in the 60s, in the 1960s. But it wasn't until 2003 that Eric Evans wrote the seminal book, Domain-Driven Design, where we figured out basically strategic and tactical blueprints to take this understanding and reshape the organization to align to such a modular architecture. So when we put it all together, the things that we need in addition to the architectural constraints for microservices, we need an investment in domain-driven design in any non-trivial domain. Has anybody actually ever done this? Like been part of or run a DDD ceremony? It's like pulling teeth. It's very slow, very expensive, very frustrating, but that's not enough. You can't just invest in DDD. You need to restructure the entire organization to align with these domains. The way we tend to build organizations is not compatible with microservices. So we need to either change our architecture or change the organization. So yeah, you need to do all the work into DDD, and then you need a top-to-bottom reorg. Good luck with that. It's hard to do. This is why the people who pull it off only do it out of desperation, not as an optional thing. And most people ignore this stuff. We need sophisticated development teams. What do I mean by that? I don't mean smart people. I tend to always work with smart people. But you can be smart, but not necessarily sophisticated. There's trade-offs. Don't repeat yourself, right? Good idea, right? Except when it's not. Microservices, one of the ways you get that agility is extreme decoupling. Common code, shared code, you're putting the coupling back in. And so microservices, you say, you know, we're going to deliberately not do that because we're not optimizing for one source of truth. And it's not even, I'm not even going to get into it, but that's not even what he's talking about, what Dave Thomas was talking about when he says a single source of truth, but whatever. But like for some developers, that's a religion. And they will die on that hill. But if you're doing microservices, generally, it's not don't repeat yourself. It's often please repeat yourself, or reuse is abuse, because we're optimizing for different things. And there's a lot of developers that can't handle those trade-offs because they've had these quote-unquote best practices that don't exist in architecture, like I say, beaten into them for so long they won't ever deviate from this. So they need to know why the rules exist and know when it's okay to break them. You need a mature development process, way more mature than most organizations are doing. And then when you go down that path, by the way, you end up with a whole new set of problems. How you're managing your pipelines. What are you doing when you get to a point where you're doing TDD and you've got all this test coverage and everything else, and your build takes 4 hours. It takes 4 hours to get that feedback, and they're queuing up and everything else. So now you're investing in all this other infrastructure to optimize this and build caches and all that other stuff. Like it gets more complicated. High automation in dev. You need an organizational commitment to DevOps. Like people have to buy in from the top to the bottom. We've all been there where, like I remember once I took a company from zero to continuous delivery, and we got very far down that line. Things were going really well. We were making huge progress. We went from doing 2 builds a year to releases every 2 weeks. And one day we had a major outage, something that we didn't have any test coverage for. So what do? We went and did things right. Even though it's like a red flag situation, we go in there, we write a test to confirm the failing case, and then we fix it. And then our test passes. We demo it. Everybody's happy. Our build is failing because some other test is breaking now. And the VP of the company comes barging in. Why is the site still down? Well, the build's failing. Why is the build failing? You demoed it. It looks good. Well, I don't know. Test isn't passing somewhere. He's like, well, just disable the test. We need to release this. Just temporarily. We'll turn them back on later. I've been in software long enough to know that temporary means permanent and later means never. And guess what? We did disable those tests. And guess what? Most of them got deleted. About 80% of our tests ended up getting deleted 6 months later because they all just decayed. And we lost a lot of really good work. Now, there was other issues. I'm not going to go into that. But we need teams being able to work completely independently. That's not how we typically operate. We need the CI/CD pipelines. A lot of this stuff. So there's a lot of things that we need. And actually, I met James Lewis, who was a thought worker who was doing all the early microservices stuff. And I was in India giving a talk, and I was giving talks, and he was giving his talk in the big room, and he called it Microservices, a decade of reflection. And he was talking about all the history of how we got here. And I thought it was fascinating. And I was also really happy that what he was talking about mirrored the stuff that I was talking about, because I was actually giving this talk there. That was this year. And after the talk, I was talking to him in the speaker green room. I said, how well was your talk received? He says, well, about half the room walked out in the middle. And I said, wow, that's rare. That doesn't happen very much in India. And he says, of those who stayed, about half of them loved it, half of them hated it. I was like, no, this is like the most important stuff. This is like the roadmap to get to the point that you can do microservices. And because he was talking about how all of this stuff converged and resulted in this architecture. But now we just tend to focus on the technical piece. And we ignore all of this stuff. And then we wonder why those star ratings don't align with our actual experience. But it's all about fit. Like for me, it's not that there's good architectures and bad architectures. There's things that fit or don't fit. This is why I called the architecture model the tailor-made architecture model, because it's all about fit. And the suits are the metaphor. Because it doesn't matter if you're tall or short, athletic, skinny, rotund, right? You have a suit that fits you really well, you're going to look good as a guy. Like, I don't understand women's clothing. I tried once to buy my wife a gift and surprise her. I got in trouble because apparently there was a subtext to the size that I had chosen. And that was insulting to her. She's like, why do you think I'm a such and such size? I'm like, because you are. Like, I looked in her closet, and I'm like, okay, you're a size whatever. Apparently that's different. Like the size numbers in women's clothing doesn't mean anything. I didn't know this. Like these jeans, right? You know what size these are? It's not like 8 or 00 or what is this, roulette? 32 inches around the waist, 30 inches in my inside leg, and a standard cut. That's the size that I wear. That's the circumference of my waist, and that's the length of my inside leg. 32-30. I can go anywhere, get a pair of 32-30s, they're going to fit the same. How do you do it? Thank you. I actually feel validated that you don't know either. But the thing is, it doesn't matter. It doesn't even matter if it's a really expensive suit, like a $5,000 suit or a $500 suit. If it fits, you're going to look good. And if it doesn't, it doesn't matter how much you paid for it, you're going to look bad. And architecture has to fit the same way, but more than one dimension. Like a suit doesn't just have to fit your body. It has to fit your style, your wardrobe. The venue that you're going to. I used to sell suits. This is kind of where a lot of this came from. For a little while, I was really into suits. I sold suits in England at a place called the Savoy Tailors Guild. People would come in, they'd say, I want an Armani suit. I'm like, hey, this is really familiar. It's like, I want microservices. I'm like, no, you don't want an Armani suit. You want to look like $1 million. Let's make it look like $1 million. And then you find out that Armani doesn't make suits that will flatter that particular person's body shape, but somebody else does. And you get the right fit. And I would ask him questions like, where are you going to wear this suit? Do you own any other suits? Because that's going to influence what I recommend. What are you wearing this to? So imagine they say, oh, I'm going to a black tie gala, or my company's doing a black tie party, and this is my first suit. Well, black tie usually implies evening attire, like a tuxedo. But I'm not going to sell this guy a tuxedo. Do you know why? Because he might wear that twice in his entire life. You can't wear a tuxedo to a job interview. Not that anybody wears suits to interviews anymore anyway. But like if you did, hypothetically. You're not going to wear a tuxedo to a funeral. But if I sell you a black suit that we can dress up with the right shirt, the right cuffs, the right, bow tie, whatever. pockets where we can dress that up so that's kind of passes black tie. But you can also wear that to a wedding or a job interview or a funeral or whatever else people wear suits for. I don't know. I don't know anymore. I still love suits. I don't get to wear them very often anymore. So it has to fit across a lot of different dimensions, not just your body. And it's the same with architecture. It has to fit the teams that are actually going to be building things. It has to fit the organization that everybody's operating within. It has to fit the business goals. It has to fit the current business climate. It has to be adaptable to the business future. And to fit across all these dimensions require extensive tailoring. So if you don't do this, you're going to end up with a suit that, if you just try to do microservices without any of this, it's going to fit about as good as that suit, which is not well. So these things we're talking about, these are non-architectural constraints. Constraints on the team, constraints on the organization, constraints on the environment. So we talk about architectural constraints. These are implementation constraints. But these types of constraints, these are the ones that we're bound by as architects. So in other words, like if the team constraints aren't there, you either have to change your architecture or change the teams. You have to change your architecture or change the organizations. So when we look fully at these constraints, microservices have fine-grained components, which requires a bunch of things. Independent deployability, which requires a bunch of things. Domain partitioning, this is how we're dividing this, that's how we're finding boundaries in our microservices. That's how we're taking those vertical slices when we need domain-aligned teams and well-defined domains, right? So there are all these additional things that never really get talked about in most of the quick start literature around architecture. And this is why I say the trade-offs are often more than we expect, but the model connects architectural constraints to the team, organizational, and the environmental requirements. So you're surfacing architecture risk up front rather than finding out after you've built it and deployed it that everything is going to hell in a handbasket. Now, again, I mentioned earlier that people tend to over-engineer. They tend to go directly to microservices because they're convinced that someday we're going to need it. And nobody wants to do the hard work of decomposing a monolith. Why? Because it's super hard. I'm just curious, anybody here, are you currently in the process of going from monolith to microservices? Anybody? What year are you in? So how many years have you been doing that now? 4th year? Okay. You're actually fairly young in the cycle. I have a large sample now, having given a lot of talks all over the world and doing a lot of training and going into a lot of companies. The mean and the mode for my stats nerds is 5 years. And somebody, I was giving this talk a while back, somebody said they were in their 7th year. And I said, okay, 7 years in, how far along would you say you were? And they're like, oh, about 80%. I'm like, okay, cool. So that you managed to finish the 80% that takes 20% of the effort. And he looks at me, he's like, ouch. I said, well, what do you want me to say? He says, you're right. You didn't have to say it, though. I said, well, fair enough. Now, 4 years now, 4 years. Now, I built and maintain a SaaS CRM for professional entertainers because I am one. And I find running an entire show business to be difficult. So I did what any developer would do. I threw code at the problem. And then it became a SaaS offering because other magicians use it now. And I thought that I would own a business. I don't. When people get really excited, hey, I can vibe code and ID in a weekend. I'm like, good luck with that. I said, because you're not going to own a business at the end of this. You're going to own a production support job. Ask me how I know. I got off the plane today. First thing I did, I schlepped my laptop into the United Club. I open up, I get on the Wi-Fi, and I deal with some production support issues. I do that every single day. I got to a point in my career where I didn't have to do production support anymore. And then I decided that I wanted that back in my life. So that's what I do now. Production support. But my CRM is a monolith. And if I decided today that I wanted to go full microservices, I could decompose my entire application, which is not insubstantial, in a week. I can go from monolith to microservices in a week. I could pull out one microservice in an afternoon. Like to take the whole thing apart to one sprint project. And I'm the only dev. So the fourth secret, decomposing the monolith is not necessarily difficult. Now you're sitting there, you're looking at me, I can see in your eyes. You're grinning and you're shaking your head. You're like, what are you talking about, Magic Man? I'm gonna get to it. Why is your experience so different? Well, you see, when I started working on my approach to software architecture that is informed by standing on the shoulders of a lot of giants who did a lot of the work before me, bless you, that I could just put everything together, put my name on it, and get no fame and no fortune, but I can say I'm a published author. So I got that going for me, which is nice. Of course, anybody at this point can prompt 500 pages into existence with very little effort. I don't know why I did it the hard way. But this periodic table of architecture, these constraints, you put them together one way, you get one thing. You put them together a different way, you get a different thing. So if I take one of the constraints out and I swap it with a different one, I get a new architecture. Evolution can be achieved by adding or changing constraints. The point is, and why your experience is different to my experience, is because AI is cool and all, but all the real challenges in technology still revolve around AV. Took us 90 minutes, by the way, to get everything up and running in this room. Just so appreciate a lot of big brains were working on this, and me. But yeah, the thing is, some of the constraints are harder to change than others, and that's the problem. So if we look at this model in action, right? We start with no constraints. What do we get for no constraints? We get a big ball of mud. How do they score in our various ilities? Not great. Nobody's surprised. But we can start adding constraints. Some kind of separation of concerns. Maybe when I click the button, it shouldn't be directly invoking the database, like directly concatenating together SQL and running it from the UI. We probably shouldn't be doing that, right? We bring in that shared database, and then we slice it into horizontal layers based on technical area, UI, API, business logic, persistence, whatever, however you want to slice up those layers. This is a really easy and natural way to think about software. This is why this is basically the de facto architecture. When I go to a client site and I say, well, what kind of architecture do you have right now? They say, we don't really have an architecture. I'm like, okay, so you're doing that. And like 99.9% of the time, that is accurate. They're just doing this. Maybe it's the clean architecture or the onion architecture or whatever you want to do. But what if we wanted to kind of evolve this further? Well, maybe we could slice off the UI, have a standalone UI, kind of like an SPA or a fat client type of thing. That's going to change some of our ilities. And or we're going to need some kind of API, so we could maybe use an RPC style API or REST or GraphQL or gRPC. They're all architecturally significant and they impact things in different ways. But as we keep going, we could keep slicing this up along the seams. This is easy to do when you're slicing along the seams. And when you bring in that independent deployability with the rest of these constraints, you get the old N-tier abstract style, the distributed N-tier architecture, which was very popular for a brief while. But everything that is old is new again. I finally realized what that smell was when people kept talking about MCP servers. And I was like, oh, it's the second coming of the WSDL. And if you don't know why that's funny, lucky you. I'm looking at you, young people in the second row. You don't know what a WSDL is, do you? Consider yourself lucky. You don't want to know. But you remember, that's why you're laughing. Yeah. Yeah. Oh, yeah. Well, we're reinventing it, but with a new name, so it's shinier. Yeah, the WSDL was basically like a 30,000 line XML file that you hoped you never had to touch, and it would describe all your APIs and endpoints and things like that. Basically, what MCP is trying to do, not very successfully, but it demos cool. So that's and we can keep going. As we need to move the needle on some of these abilities. By the way, this is all design time feedback, because this idea of these atomic primitives and how they're so deterministic in how they impact your architecture that you can actually weight them for design time feedback. So like I can see how every decision is going to impact different entities, where the trade-offs are at design time. We don't have to spend 2 years building it and ship it to find out it's not going to work. I can find out right away. But we can keep going. If we need to bring up scalability, we can bring in CQRS into the interior. So you can keep tuning this, and all we're doing is we're adding and changing constraints. Do you want to go back? Did you get it? But this isn't particularly exciting. But it's useful to talk about. So this is a distributed architecture, but this is not microservices. Like people who do microservice kind of look at that and like, nobody does that anymore, except we do a lot of the same things over and over again. It's just we independently discover them over and over again. Basically, everything that we've learned in the history of software, we have to independently rediscover about every 7 years. We talk about distributed systems. I meet developers every single day who are learning for the first time the fallacies of distributed computing. Peter Deutsch gave that to us in the 70s, but we have to relearn it. We have to relearn most of the important lessons. And what makes it even harder is we rebrand it every time we relearn it, because a lot of people don't know what came before. But that's not microservices. How do we get to microservices? Well, to quote Everlast, I don't know why I put this in my slide, except it was the middle of the night and I was listening to some music station, Pandora or something, and this song started playing, and I was like, yeah, that's apt. You know where it ends? Yo, it usually begins. Depends on where you start. So we go back to our layered monolith. And what if, instead of the horizontal slices, what if we took vertical slices? Like, that's ultimately what you're doing with microservices. You're taking vertical slices top to bottom, carving those off into standalone microservices. The reason it's so hard is there are no seams in any of these layers. So you actually have to unpick everything. You have to figure out where those boundaries are. Usually there's an experimentation process as well, trying to get these things. So we take those vertical slices and we can keep them. And so if we just change one constraint, instead of partitioning by technical area, we partition by domain boundaries. This is the bounded context. This is some of the DDD concepts that are very instrumental to microservices. Well, now we have new requirements for domain-aligned teams and well-defined domains, but each one of these becomes a mini microservice embedded in the monolith. Now at this point, these little standalone modules, I can take them out extremely easily and deploy them as standalone microservice. But because I'm cutting again on the seams. In fact, if we follow this down to see how this works, I mean, basically the idea is, and this is some of the magic of microservices, that if I make a change in the database, that means I need to change the persistence layer, the business logic layer, the services, the UI. I've got to change everything. What's my testing scope? The whole system. This is why we say that a layered monolith is not great at agility, because every time we change something, we have to retest everything. Whereas if we look at this kind of domain partition monolith, well, I can make a code change here, but because everything in these modules, these are like separate packages or separate assemblies, everything in here is scoped internal, and they're all linked at compile time. So that means there's no way for this module to peer into that module except through published interfaces. Everything else is internal. So if I make a change and I haven't broken any contracts and my integration test pass, my testing scope is here. And meanwhile, another team is making a change over there, and another team is making a change over there, but our testing scope gets much smaller. We can work together because everything is we have a lot more modularity in the system. Now, this tends to fall apart when there's a database change involved, because usually we're still coupling in the database, and so that can bring in some risks. So we add one more constraint to this architectural style, and that is we're actually keeping one shared database, but we're partitioning it with schemas or different catalogs or different databases within the server, that every module has its own connection string with its own permission. And so your module can't see my tables and my module can't see your table, which is how microservices work. Every microservice gets its own database for the most part. So we add that constraint and we get the modular monolith, which is a very pragmatic architectural style. And we can keep going. You know, we can slice off the UI if we want, make a standalone UI. We can take groups of these and deploy these independently. And as we keep kind of tweaking these, we add the independent deployability, we end up with the service-based abstract style, which is like mini services. Microservices are fine-grained. These are kind of medium-grained. This is kind of the happy middle. This is something a lot of people call microservices, but they're like coarse-grained or medium-grained microservices. And we can keep kind of moving down this path because every module has its own connection string. We can start taking apart the database as we need to. We can make these more fine-grained. And it becomes very easy to evolve in the direction of microservices. So the thing is, when you are cutting along the dotted line, right, going from the layered monolith to the distributed end tier, that's an easy, natural evolution. You're breaking everything apart at the seams, right? Across existing boundaries, straightforward. Going from layered monolith to those vertical slices and all of that, that's not. Changing the model partitioning is difficult. So I put together, this is a simplified version, but I put together a new taxonomy. This is a small simplified version, but the thing is, as you travel down the taxonomic tree, I start with the constraints that are hardest to change. Because going from monolithic to distributed, not difficult. Going from technical partitioning to domain partitioning is. So it's not necessarily difficult, but decomposing across module boundaries is. We got to wrap this up. I think Mary said lights out at 8:30. So I'll wrap the last couple things up. Two really important things. One, granularity doesn't have to be absolute, right? There's no rule that a microservice can only be 100 lines of code or something like that. Micro is in scope, not micro is in size. But sometimes it's going to make sense to have a couple fine-grained services, maybe a couple lambdas or Azure functions or whatever you're using, and maybe having a couple of these bigger components in there as well. But let the metrics drive your decisions. Look at where the hotspots are, look at where the loads are, look for things like distributed transactions, different ways to measure your architecture, just useful things to keep in the back of your mind. Just be deliberate about every constraint that you're prescribing. Start coarse-grained and get finer. Don't start too fine. It's easier to whittle away more than it is to kind of put things back together. Avoid distributed transactions wherever possible. Usually, I mean, sometimes you need to do distributed transactions, but I promise you, you really don't want to. You really don't want to. It's going to keep you up at night. But so usually when I see distributed transactions, I treat that as a smell, not an absolute, but it's like an architecture smell. It's like, okay, we might be too fine-grained here because every time I need to do anything, I need to orchestrate 10 or 12 microservices. Where's your fault tolerance now? One goes down, everything goes down. This is anathema to the ideas behind microservices. Just remember, granularity need not be absolute. Multi-grain services are fine. Fine-grained, medium-grained, coarse-grained. Have one monolith and you cut, like honestly, I don't want, my system could be microservice. I don't want to. I know how to do it. I've done it a bunch of times. I don't want to. It doesn't make any sense for me. But if I did, realistically, I would carve out like 3 or 4 microservices and everything else would stay in the monolith. And that's totally cool. That's not a failure, as long as you're delivering value with the architecture. The last one I'll leave you with is monolith first is often practical. Start with, if you want to go to microservices, start with that modular monolith. Because then at any point you can start pulling those individual microservices out. But you might find that you don't need to. Do it when you need to, not because you want architecture that confers bragging rights. Now, one of the problems with this is, I mentioned there's a lot of enforced modularity in there because everything in every one of those modules is scoped internal. But maybe, we're racing towards that Friday afternoon deployment that we don't normally talk about in polite company. And you really want to go home, you want to have a calm weekend, so I'm just going to take a little shortcut. Nobody's going to know. And before you know it, your architecture has decayed beyond all recognition. So what about that? Well, that's where we want to put in automated architecture governance. I talk a lot about that in the book. If you email me, I'll send you the chapter. You don't have to buy the book. But you want to have these controls in place because you want to be prepared for someday, but you don't want all of that to erode on your way to someday. So monolith first is often practical, provided you have adequate architectural enforcement and governance in place. So we talked about the 6 secrets. Nobody really wants microservices. They want something they think microservices will give them. Figure out what that is. Figure out the best way to get it. Maybe microservice is the best way, maybe not. But don't be black and white, one-dimensional, ultra reductive in your thinking about architecture. Be more nuanced. There's no single definition of microservices. Don't let the flat taxonomy fool you. Also, you can't just prescribe microservices. You need to be more precise. The trade-offs are often more than we expect. One person's 5 stars, another person's 1 star. Decomposing the monolith is not necessarily difficult, but decomposing across module boundary, decomposing within module boundaries is. Don't be fooled into thinking that you can't grow into microservices over time. Take a more holistic approach on your architecture to balance cost, complexity, and scale. And monolith first is often practical. Use sophisticated approaches to design an architecture that fits now and can evolve as your needs do. And with that, I will say thank you, save for a couple of plugs. But first, I'll say thank you. Got a couple quick plugs. Mary mentioned API Conf. If you want to come to the Architecture Conference, December 8th through the 11th in Clearwater, Florida, where the weather is much nicer than it is here in Chicago. I lived up in Evanston for a while. I've had some Chicago winters. I do not recommend. I've also spent a lot of winters in Clearwater, Florida. I do recommend. Sugar white sandy beaches. Every room in the hotel has a sunset view. It's beautiful. So definitely check that out. Use ARCH25MC4 and save $400. There's also other codes on little postcards. Take those with you, please. This is the book. If you do want to buy it, you can. I will get, if everybody here buys a copy of the book, I will have enough money to take my wife out for fast food. So, yeah, that 4.2 star McDonald's is looking pretty good now, isn't it? The third thing I'm very excited about this, in the middle here, Dev Random TV, that is our pizza sponsor today, which is my new YouTube channel. So we're uploading about every 2 weeks. This is old school, high effort, no AI slop, meticulously written, researched, edited, produced to create interesting, compelling, high quality stuff that give you insights that you just won't find anywhere else in an interesting and entertaining package. We just released a fourth episode, which is cheat codes for life if you're dealing with burnout. 2 weeks ago, we had kind of an interesting take on AI, talking about some of the risks that nobody's talking about. It's not killer robots, it's us being fooled. and we are being fooled, and it is quite terrifying. And nobody's really talking about that stuff. So that one's a little darker. The one before that was some old stories of my mischievous youth as a phone phreaker. If you don't know what that is, you should find out. It's a super interesting story. But also, it is very, very pertinent. Even though the phone phreaking stuff doesn't work anymore, it's very pertinent because the one vulnerability that made it possible for anybody in the world to whistle and get root access to the entire global telephone network is the same vulnerability we just built into all of our state-of-the-art AI, all of it. And we can't take it out, and we can't fix it, and we can't patch it. So it's an interesting story with some interesting modern effects. And the last one is about building breadth rather than just depth. More coming. Super proud of the channel. So definitely give us a sub. Watch one of the videos. That would be super nice. And want to thank CJug. And I want to thank No Fluff Just Stuff, because the people who produce these conferences, ArtConf, the Great Lakes Software Symposium, API Conf, Tech Leader Summit, they paid for me to be here today. And then the YouTube channel paid for y'all's pizza. And Mary is tirelessly helped organize this so I could finally get out here. We've been talking about it since April, I think, since the last Arc of AI. So, and thank you all for being here, because y'all are awesome. All right.
That's a comment from YouTube. He said, Michael, use the money from the book to come to Brazil.
Yes, I'm coming to Brazil in January. All right, everybody buy a copy of the book and some subs. And then that way I can fund this adventure to Brazil. And in fact, the latest episode that dropped today, there's a lot of Brazils in there. We have samba music, we have carnival. It's and it's all about, modern tech worker burnout. My stories, other people's stories, and what to do about it. The cheat codes for life. So thank you all. Any closing words? Questions?
A question, but just a last thought. If you're mentioning microservices, they're not making sense in the 90s and then making sense in the 2000s. I think one thing that we often don't appreciate is that hardware was a key component there. Hardware wasn't cheap enough and powerful enough, and networking wasn't there.
And we also didn't have virtualization.
Microservices should be working then. When hardware got good enough, it made microservices possible. And I think one of the things that we need to be aware of is that hardware has marched on to the point where microservices might have made sense in the past, it may not make sense anymore, just because we get so much more out of the same hardware.
That's a good point. Okay, so I'm going to repeat that for the folks on whatever we're streaming this. That one other aspect of microservices not making sense in the 90s, making sense in the 2000s, one of the variables was hardware. That we just didn't have the kind of hardware that would make that level of virtualization and kind of building that compute fabric possible. And then you mentioned that advances in hardware and I would say advances in virtualization as well help that. But we've continued to progress, and so to your point, we're also not under the same limitations we were 10 or 20 years ago. That we don't really have to worry, like we don't even think about hardware anymore, except in the context maybe of like an EC2 instance or something like that. But I have no idea what metal or metals that's running on, and I don't care. And we're kind of abstracted away from that. And so, yeah, that's a good point. That it's also it's also a response to hosting constraints that don't necessarily exist anymore. Yeah. Oh yeah.
Single VM can handle thousands of requests per second easily, and we don't even think about it. We divide it up anyway and make a mess and make it slower than if we just left it on one machine.
Yeah. Oh yeah. No, that's the other thing is there's a massive performance penalty that comes with microservices. You get more scalability, but at the cost of performance, because because network latency, bandwidth limitations, which goes back to Peter Deutsch, which is one of the seven fallacies. The original seven fallacies of distributed computing is latency is zero, bandwidth is infinite, the network topology doesn't change, the network is secure, the network only has one administrator, transport cost is zero. There's another one in there, and the seventh one. Those are the seven fallacies of distributed computing. But the network. There's a cost. There's I heard somebody describe it as the distributed computing tax. And as soon as you cross that line from monolithic to distributed, you have to pay the distributed computing tax. And I was like, that's actually a good way to think about it. But any other questions or comments?
Just wondering what your thoughts, because you talk about AI. So do you think like agents are like a form of special case of microservices, or agents
a special case of? Are agents a special case of microservices? Not in the way that I think about. I think an argument could be made for such an analogy, but not the way that I think about microservices. But I don't even agree with when most people talk about agents. That like most people, when they use the term agent, they're being deliberately misleading. They use the term agent to mean a chatbot that can do some things while connected to a database, which is also known as a chatbot. An agent is capable of taking actions without the user interacting with them. Basically demonstrating agency to take actions without having to be told. Otherwise it's just really fancy natural language scripting. And that didn't work with AppleScript. And it's not going super well with LLMs. But I think there's some interesting kind of potential in there, but I think we're still a little half-baked in our implementations. But I have a bias. I spent a lot of time. Well, so I was watching on the flight in today. I was like, it's a 2.5-hour flight. I'm gonna watch a movie. I was watching Hidden Figures, and if you remember the film, it's taking place during the space race in the 1950s and 60s, and at one point they're sending the first manned mission into orbit. And the problem is they have figured out how to build a rocket to put something into space. They figure out how to put the capsule into orbit, but they can't figure out how to go from an elliptical orbit to a parabolic orbit. And the big challenge, and they're getting closer and closer and closer to launch date, and they're like, yeah, we don't know how to bring our astronaut home. The math doesn't exist yet. And then our hero, the human computer, because back in those days, computers were people, not the machines. We didn't have those machines. We didn't have that concept yet of like electronic computers. They were people. It was a job. Computing was a job. She's like, everybody's puzzling and nobody can figure this out. And she looks at it and she says, we don't need new math. We need old math. And everybody's looking at her like, what? And she said, no, we've already solved this problem. We can use Euler's method. And everybody's looking at her like she just sprouted the second head. And one of the guys actually says, Euler's method, that's positively ancient. I didn't know mathematics had a shelf life. But it's the same in technology. There were so many people that were doing important work that was ahead of their time and solved problems that they knew were coming, but the problems hadn't arrived yet. So when we saw the solution, it didn't make any sense. And now we live in a world where everything changes so fast that it takes all of our focus and all of our energy just to keep up with like the last 6 to 18 months. And we lose the benefit of everything that we're built on top of. And that's why we keep having to relearn the same lessons over and over again. We keep having to rediscover the same ideas over and over again. we keep going in circles. So I spent a lot of time looking backwards. And that gives me a much broader set of tools to solve modern problems. Because it's like, what's in your toolbox? And in this like bloodbath of a market, do you want to be the person who has the exact same skill profile as everybody else? Yeah. I got the latest version of React. I got the latest of this. I got the latest of that. Cool. So does everybody else. But can you bring modern techniques and modern tools and combine that with timeless wisdom from the field that most people forgot? Like, that's why the 10x developer isn't the one who is lapping you in terms of output in a real sense. It's the person who's asking the right question, adapting based on the dynamics of the situation rather than going from a rote playbook. So that's I don't remember why I started to say this, but agents and microservices, yeah. Oh yeah, thank you. Thank you for popping the stack for me. So the thing is, like, a lot of the stuff we're doing with agents, we're not benefiting from the people who have solved the most pressing problems. Like, the most pressing problems for the kinds of things we want to do with agents were solved in the late 90s and continue to evolve and get formalized in the standards over the next 25, 28 years. But we're not paying attention to any of that. And the people at the state of the art honestly have no idea how to solve the problems because it took 30 years to figure out how to solve the problem the first time. But if it's not in your toolbox, you're back to trying to rewire your breaker box, and all you've got is a butter knife to try to unscrew the breakers and things like that and rewire it. It's so I'm all about I'm really interested in the timeless stuff. But yeah, so like a lot of the agent stuff, that's where I'm doing a lot of my current R&D is how to solve the fundamental problems of like make agents actually work, basically get us to Star Trek universe. And in fact, that's the metaphor I use when I started laying out my vision a year ahead of MCP. And then MCP rolls around a year later, and I'm like, cool, that's about 1/3 of what I designed. Yeah, and it's getting worse. But it's cool, and people are excited about it. Now we just need to flesh out the rest of the thing. It's about that time. But anyway, I'm going to pack up. We'll probably need to get out of here soon, but I'll be around if you will have more questions. And
thank you so much.
Oh no, thank you. I love coming out to Chicago.
Thank you.
Love seeing y'all, and hopefully I'll see you in Florida or at the Great Lakes Symposium, or maybe in the comment section on the YouTube. But thank you so much.